This is Anita, Assistant Professor of Chemistry from V.V. Vanniyaperumal College for Women, Virudhunagar. In this module, we will see about the different gas laws and the assumptions behind the kinetic theory of gases. In our previous model, we see about the Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, and then we have come to the conclusion of the derivation of the ideal gas equation and the gas constant in it and the different units of gas constant. On continuing with this is the third module of the gaseous state, and in this we see about the Graham's law of diffusion and then Dalton's law of partial pressure, followed by the assumptions involved in the kinetic theory of gases. First we get into the Dalton's law of partial pressure. Before getting into it, we have to know what is a pressure and what is partial pressure. Pressure is the tension exerted by the gas due to the collision with its container or with the another molecules. That's the pressure. If a container contains a mixture of gases, that is the combination of two or more gases, each gas exerts its own pressure, that is called as the partial pressure. That is, it is a part of the total pressure, that is called as the partial pressure. If a single type of molecule exerts pressure, then it is partial pressure. Then the mixture of these gases, that is the combination of the gases, exerts the total pressure. This Dalton's law tells us that the total pressure of a mixture of the gases is equal to the sum of the partial pressure of these constant gases present in it. Consider here there is only one type of gas of the pink type. In this case, there is another type of gas of the violet type. That is gas 1 of certain amount and gas 2 of certain amount. In this case, it is a mixture of both the gas 1 as well as the gas 2. Here the pressure exerted by this both types of gases is equal to the total pressure. Here, the pressure exerted by these type of gases alone in this container is called as the partial pressure. Therefore, here the pink type of molecules is of little amount, whereas the violet type is in of greater amount. Therefore, this is the combination of these two type of gases. Therefore, the partial pressure exerted by this pink gases depends upon the number of molecules present in it, and the partial pressure of the violet type of molecules depends upon the amount of the molecules present in it. Therefore, the partial pressure as well as the mole ratio will be equal to the total pressure, or the product of the partial pressure, total pressure and the mole fraction will gives the partial pressure. Therefore, here mole fraction is an important concept, that is the fraction of a single type of molecules present in the total type of molecules. Therefore, it depends upon the total pressure and the mole fraction gives the partial pressure. Here again we see that the total pressure is the combination of the partial pressures, or the partial pressure will be the product of the mole fraction and the total pressure exerted by the combination of the molecules. The next comes the Graham's law of diffusion. Before getting into it, we have to know what is a diffusion. When two gases are separated by a membrane, or when it is in contact, one molecule begins to move into the core of the another molecule without any external forces. They mix spontaneously because both the types of molecules are in constant random motion and they are moved towards each other. This process of mixing of gases by the random action without any external support is called as the diffusion. This diagram tells us the diffusion of this blue molecule with that of the pink molecule without any external conditions. How these molecules move and what the mass is the determining factor. If a gas molecule is having high mass, then it moves slowly. Therefore, its diffusion rate is slow. If a molecule is having low molecular weight, then it can diffuse at a faster rate because its rate of movement is very high. As it is having small mass, it has the ability to move faster. Therefore, the rate of diffusion also increases when the mass is small. The reverse happens when the mass of the molecular mass of the molecule is very high. Therefore, this Graham's law of diffusion states that under the same condition of temperature and pressure, without any change in the temperature and the pressure, the rate of diffusion of the different gases are inversely proportional to their molecular masses. If their molecular mass is low, then the rate of diffusion is high. If the molecular mass is high, then the rate of diffusion will be low. Therefore, this Graham's law infers that it is proportional to the square root of their molecular mass. The molecular mass of the gas 1 is inversely proportional to the molecular mass of the gas 1. Therefore, R1 divided by R2 is equal to root of M2 divided by M1 is the mathematical form of the Graham's law of diffusion. And that's all about the gas laws. Next, we have to see about the kinetic theory of gases, and it is a fundamental concept. We have seen that the fundamental concept is a gases consist of large number of molecules which are randomly moving in a random movement, and it collides with the walls of the container. This is the fundamental concept before studying the motion of the molecules. That is, the study of the motion of the molecules is the kinetic molecular theory, or simply the kinetic theory. And before study that, we have to do some of the assumptions. Then only the study can be easier. Then it can be expanded in some other way. The first assumption is a gas consists of extremely small discrete particles called as molecules dispersed throughout the container. Here only the 9 molecules are here, but it is dispersed throughout the container. The actual volume occupied by the molecules of the gas is very much negligible when compared to the total volume occupied by the gas. Even a few molecules can occupy the entire room without any constraints. That is the first assumption. That is the property of the gaseous state also. Whatever the space available, the gas molecules begins to expand itself without any external influence. The next assumption is the gas molecules are in constant random motion with high velocities. This diagram clearly indicates that all the gas molecules are not moving in the same direction. All the molecules are not moving in the same speed. They are moving in a random manner, that is of any direction and with different speeds also. But the velocities are not small. All of them are moving with a very high velocity. Due to their random motion with the high velocity, the molecular collision takes place between the molecules or with the walls of the container. During its motion, the molecules collides with each other or with the walls of the container. Due to this collision with among themselves or with the container, the pressure of the gas is introduced. This is the second assumption. Then we can see that the distance between the molecules are very large. Therefore, the molecules are moving in an independent manner. That is, the movement of one molecule is not influencing the movement of the other molecules. Each molecule moves in its own pace with its different speed. Therefore, the molecules are in random motion. The motion of the one molecule cannot influence the motion of the other molecule. Next, come to the fourth assumption, that during motion, the molecules collide with each other or with the walls of the container. All that collisions are perfectly elastic. The elastic means that is, there is no change in the kinetic energy of the molecule before and after the collision. Whatever the kinetic energy possessed by the molecule before collision is equal to the kinetic energy possessed by the molecule after the collision. And next, the next assumption is the pressure of the gaseous molecule is alone due to the pressure collision between the molecules on the walls of the container. That collision brings pressure to the gaseous molecules. The next important assumption is due to its motion, the molecule possesses kinetic energy, and this kinetic energy totally depends upon the temperature of the gas. If the temperature increases, then the average kinetic energy of the molecules also increases. If the temperature remains the same, then the kinetic energy also remains the same. If the kinetic temperature decreases, then the kinetic energy also decreases. These are the basic assumptions of the kinetic theory of gases. By making use of these assumption alone, we can study the different movements of the different movement and the process involved due to its motion of the gaseous state. And by alone studying these type of reactions, we can come into the other physical states like liquid and solid. These are the basic things one have to know in order to study the kinetics of the further reactions. With this, I end this module, and in the next module we see about the derivation of the kinetic theory of gases and what are the assumptions which does not hold good while deriving the equation and in the practical applications. Thank you.